Welcome back. And today our talk is on the lesson, the Raman Effect. So in this lesson, the Raman Effect, we're not going to discuss the entire biography or the works that he has performed. We are exclusively going to focus on the Raman Effect. And you can ask me, no, you might be knowing the Raman Effect is all about because you might have learned, you might have taught this lesson in your intermediate and as well as in, if I'm not mistaken, some of you might have covered that in your 10th class. We are exclusively studying this Raman Effect. So, if I'm not wrong, you can ask me a question. Why they have actually given this one? So they talk about the inventions, right? So he's the one who actually invented this new technique called the Raman effect. And till now, till now, if I'm not by the time, before 1930, before 1930 or 1912, 1928 or 1926, like that. So nobody knows why seawater in blue color. He is the first person who actually proved because of particular reason the entire seawater going to be in will be in blue color, not only seawater, and of course when we go to a pool, when we go to a river, we can notice that the entire water is going to be in blue color. So why this entire water going to be in blue color? That is what we're going to discuss in detail in this video. And before to that, we're going to see his educational background, his childhood, and followed by his research areas and how he actually no got impressed in order to find out why the seawater in blue color, and later how he actually achieved the Nobel Prize. So all these things will be discussed now. Let's see what is Raman effect is all about.
Yeah, let's see what the Raman effect is all about. So, in the year till then, I don't think that there were no Nobel Prizes were awarded. But for a great work, a man from India, he actually no 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 became popular in the year 1930. You know why he became very popular? Because he's a person who has got Nobel Prize for physics, and that too on a groundbreaking discovery of the phenomenon called the Raman effect. His name is Chandrasekhar Venkat Raman. He is a man who actually made this great achievement in the year 1930 for his great work, for his great scientific work in physics. Let's see more about this work. And if you see the educational background, he's actually from Tamil Nadu, and he has completed his education, like schooling and as well as in college, from Presidency College, which is located in Chennai. And as he was having the impact of his father was a professor, a physics professor, and he's very much interested. He's very much interested into this physics and wanted to pursue scientific research. So now and then he goes to this cultivational science research center in order to pursue something over there. So even then, instead of despite clearing the civil service competitive exam and becoming the deputy accountant general in Calcutta, in the year 1917. So the passion actually led him to give up this administrative position and made him to become a professor of physics at Calcutta University. See the passion here, what he is carrying, and that passion actually led him to resign, being a deputy accountant general. See here, after becoming a professor of physics, what he actually done. So if I'm not mistaken, his first step, his first trip was to London, and where he was actually called as a delegate at the university's congress in the year 1912. So the delegate talks is all about optics and acoustics, and where he is going to give a talk over there. But by the time, there were two famous physicists who are J.J. Thomson and as well as Lord Rutherford. These people already acquainted with Raman significant study in the field of optics and as well as acoustics, but there isn't nothing to be done. But he's a person, he wanted to prove something over there. So what happened here? Raman had already studied classical percussion percussion instruments like tabla and mridangam, and he wanted to prove, and he wanted to no, no, show how these mathematical relationships that produce the pleasing effects of the sounds when we actually play tabla and as well as mridangam. So this is how he actually started, embarked his first trip to London. And I see. So when he was going, so when he was going to London, um, I guess earlier days, those days, I don't think they're not that much advisable, or the planes were not there. So most of the times they have to travel on a ship, on big ship. So if you wanted to travel to London, it takes around 9 months, 9 months, 9 months it takes easily. So it was a sea voyage to London. So what actually happened? The ship was going in Mediterranean Sea. What happened when they were traveling, when they were voyaging on that sea? Something triggered in his mind. What is that trigger? The blue color of the water. If you go to seas, if you go to any ocean or sea, we're going to experience the entire the water is going to be in blue color, isn't that? Even when we go to rivers, or when we go to big pools, and we're going to see the entire water completely going to be in blue color, but nobody knows why they are in that blue color. And when he was traveling to that London, he came to notice two assumptions were existing. What? Two assumptions were existing. So what are the two assumptions? The first one is here. The it is believed and as well as accepted that the blue color of the sea was actually a reflection of the sky. So obviously, if you put anything underneath, on the top of something, definitely you're going to see the reflection of it, isn't that? When we see our face in the water, we're going to see our reflection. Just like people do believe, because of the reflection of the sky, uh, the entire water turned into blue color. That is what one assumption, which is actually believed. And second one is here. It is actually confirmed and proposed by one of the famous physicists, whose name is Lord Rayleigh. So you know what he told? It is not exactly that. It is not exactly the reflection of the sky, but it is the minute particles in the air scattered the blue wavelength from the sun's white rays. So here you can see the minute particles in the air. So the blue wavelength from the sun's white rays. So when the sun's white rays falls on this seawater, the minute particles which are in the air, they are actually that air particles are actually scattered. So when these air particles were scattered, and definitely you're going to experience the water is going to turn color, that is blue. So that is these are the two assumptions which were actually given, or no, or in the existence by the time he came to know. And see here, there are going to be two assumptions. First one is here, the blue color of the sea was actually a reflection of the sky. And second one, it is confirmed and proposed by Lord Rayleigh that it is not exactly the reflection of the sky, but it is the minute particles. The minute particles in the air, so scatters the blue wavelength from the sun's white rays. So for the sake of that, well, because of that, so the blue color, the blue sea water turns into blue color. So these are the two assumptions that we had by the time he came to know about this one. But somehow Raman wasn't convinced. He was not actually satisfied with that two assumptions. So finally, what happened here? Something is actually happening, or something is actually making this blue color, this water into blue color. So then what he speculated was this: the blue color of the sea could be caused by the scattering of sunlight by the water molecules. Now, what happened here? So you can observe here, the seawater, the color of the seawater could be caused by the scattering of sunlight by the water molecules. When this sun rays directly falls onto these water molecules, seawater molecules, on the sea, on the seawater, so water has some molecules. So when they were scattered, so whenever, because water is not going to be constant. They move, they scatter. So whenever they scatter, when the sunlight falls on this scattered water, so definitely you can expect it to see the color of the color of the sea. So that is how the blue color actually came into no the that is how the color of the sea will be changed. So in order to make it more effective, and in order to make his talk more stronger, he used a polarized nickel prism on a sample seawater in order to show that light was indeed scattered by the water molecules, a phenomenon that he called as molecular diffraction. So when this happens, then only with the help of sunrise. So when this molecular diffraction happens on the seawater, so then we can able to see the water in blue color. So this is what he actually speculated and made an experiment. In order to prove that, he used nickel prism. And later, as soon as he returned from London, he decided to research in three areas. The first area is here: the scattering of light by liquids, the scattering of X-rays by liquids, the viscosity of liquids. So, fortunately, what happens here? So, when he was working on the first one, the scattering of light by liquids, so that actually fetched him the Nobel Prize. Next, and two people actually helps him to um, achieve this great thing. So they are K.R. Ramanathan and K.S. Krishnan. So these are the people who actually these are the people who are associated with Raman. So in order to conduct this experiment. So what happened here on February 28th, on February 1928? What happened? Raman and his associates had irrefutable proof of the modified radiations observed in the scattering experiments due to molecular vibrations. So when they are actually still working on that, so they are still working on the seawater. So they noticed it's something. They noticed something that there is a modified radiations observed. So these radiations were completely modified, and they were scattering due to molecular vibrations. Because of this molecular vibration, because of this molecular vibration, you can expect it to see the water will be changed into different colors. And even if I'm not mistaken, when we go for functions or when we go to functions, they actually put some different colors on the water. So whenever they go for light, when the light turns into red color, blue color, and even you can happen to see the water going to be in that color, maybe a red color or maybe blue color or whatever it may be the color it is. It is happening because of molecular vibrations. So this is hence proved in the year 1928 in the month of February. So this was actually announced and in the month of February 28th they noticed, and they officially announced this one through the Associated Press on 29th February 1928, and they gave more confirmation. They gave more confirmation about this molecular vibrations on 8th March 1928. And later, so what happened there? He was actually happened to welcomed by South Indian Science Association on 16th March 1928, and he has to address the gathering, and this is how he was actually addressing. I propose to speak to you this evening on a new kind of radiation or light emission from atoms and molecules. This is what he was actually talking about. But his confidence is completely different because because by this time the experiments were replicated and findings were confirmed, and he sent a detailed notes to Nature, where these people are actually experimenting, and they were actually taking some confirmations when it comes to the findings and replications. So finally they announced the name Raman for the Nobel Prize. This is how it actually happened. And he actually assumed, he actually dreamt about this Nobel Prize. At a meeting in the year 1924 in the Royal Society of Fellows, he was actually announcing himself that he's going to get the Nobel Prize for in physics within 5 years. I'm gonna get. So this was actually announced in the year 1924. And in the year 1928, sorry, in the year 1930, in the year 1930, it is officially confirmed that he has given Nobel Prize for the groundbreaking record. Because till then, people were actually talking about something about the seawater, and most of the people are not actually aware. And some of the people were telling that it is the reflection of sky, but which are not actually make it a strong evidence, which are not actually given a strong evidence to believe in. And even there was a famous no, physicist who is Lord Rayleigh. He also told that he tried to tell that it is not because of the reflection, but it is because of no molecules which are in air. When they are actually scattered by the sunlight, the seawater actually turned into blue. Somehow he was not at all completely, no, he was not at all satisfied with that answer. So finally, he noticed that because of molecule vibration on water, this actually turns into blue color. So he made it strong. He made it strong and wanted to do some research. And when they were researching on this one, and finally they found the exactness. They finally found irrefutable proof that the molecular vibration. So because of that, the entire water going to be turned into blue color. So this is how he actually no, assumed about himself, and the inevitable prize, uh, that is Nobel Prize, actually now given to this Raman. And let's see what actually Raman effect and Raman spectroscopy. So Raman effect is nothing but, so when a light beam travels through a medium, it is deflected by the molecules in the medium. So when it is deflected by the molecules in the medium, you can expect you can expect it to see a different color. Normally, water is going to be in white color, but when a light beam travels through a medium, so medium could be anything for that matter. So when it is deflected by that molecules in the medium, you can actually expect it to see the color of the water in the water the color of the water will be changed. And that is what actually Raman effect deals with. And moreover, when it comes to Raman spectroscopy, so let's see what is Raman spectroscopy. A small part of the emerging light beam, after being deflected by the molecules, had you can expect it to see a different wavelength and as well as a different color from the phenomenon. So later, which actually initiated for Raman's spectroscopy. So this is the difference between a Raman effect and as well as a Raman spectroscopy. So from the Raman effect to the Raman spectroscopy actually came into existence, because there is a different. They're going to find a different wavelengths in color from the phenomenon. So that actually led them to go after Raman's spectroscopy. Let's see how this Raman spectroscopy used in different applications. So this is actually used in order to study of the molecular structure of compounds. People are actually using these days. Raman spectroscopy is actually used in the study of molecular structure of compounds, and also the handheld scanners for detecting drugs and explosives. If you ever been to what do you call that, airports, they're gonna check you. They're gonna check you, and also if you go to any international airports, they check your body whether you're carrying any explosives or drugs and all. And I'll give you this example. You might have seen this Xerox machine. So when they place a paper on the screen, so a light beam will come and go. So there is a scanner. So that will actually scans everything. So only that light matters a lot. And later, this Raman spectroscopy is also used, or people are actually using in the pharmaceutical industry, and also they are using in medical diagnostics. So this is how this Raman spectroscopy applications were used in these different fields. This is what is all about the lesson, the Raman effect. And when our class, when we're going to have class, we'll be having a detailed explanation about this one, about this topic called the Raman effect. So if you still have any doubts regarding to this one, and you can actually give me a call or else ping me on WhatsApp. Thank you.